Hi friends, welcome to all. In this video, we are going to discuss CCNA version 7 lab activity, that is configure basic router settings. Before coming to this lab activity, friends, if you are watching our channel first time, or if you like to get this type of technical videos in future, consider subscribing. Also, don't forget to enable that bell icon near to the subscribe button so that you will get a notification message whenever we upload a new video. And also, if you like to get more technical contents or if you like to contact our team, you can visit our website. Link you will get from our description below. Now back to our lab activity. Here we can see the topology what we have to design. Here is our addressing table. IPv4 and IPv6 are used. Coming to the objectives. In part 1, set up the topology and initialize the devices. Cable equipment to match the network topology, then initialize and restart the router and switch. In part 2, configure devices and verify connectivity. Assign static IPv4 and IPv6 information to the PC interfaces, then configure basic router settings, then configure the router for SSH, and finally verify network connectivity. Then in part 3, display router information, retrieve hardware and software information from the router, then interpret the output from the startup configuration, then interpret the output from the routing table, and finally verify the status of the interfaces. Okay, we will go through this background. This is a comprehensive lab to review previously covered iOS router commands. Okay, in parts 1 and 2, you will cable the equipment and complete basic configurations and interface settings on the router. In part 3, we will use SSH to connect to the router remotely and utilize the iOS commands to retrieve information from the device to answer questions about the router. For review purposes, this lab provides the commands necessary for specific router configurations. Also, they given a note here. The routers used with the CCNA hands-on labs are Cisco 4221 with the Cisco iOS XE release 16.9.4 with this image. Okay, the switches used in the labs are Cisco Catalyst 2960 with the Cisco iOS release 15.2. Okay, with this image. Other routers, switches and Cisco iOS versions can be used. Depending on the model and Cisco iOS version, the commands available and the output produced might vary from what is shown in the labs. Refer to the router interface summary table at the end of the lab for the correct interface identifiers. Again, a note. Make sure that the router and the switch have been erased and have no startup configurations. Consult with your instructor for the procedure to initialize and reload a router and a switch. Anyway, here we are using a fresh router and a switch because we are using our simulator Cisco Packet Tracer. Here we can see the required resources for this lab activity. We required one router model. We can see Cisco 4221 with the Cisco iOS X release. Then one switch, two PCs, console cables to configure the Cisco iOS device via the console ports. Anyways, here we are using Cisco Packet Tracer, so no need to connect through console cable. Then Ethernet cables as shown in the topology. Yes, when we do in the real time, we have to connect with these console cables to do the basic configurations. Now they given a note here. The gigabit Ethernet interfaces on Cisco 4221 routers are auto sensing, and an Ethernet straight-through cable may be used between the router and PC-B. If using another model Cisco router, it may be necessary to use an Ethernet crossover cable. Now, coming to the instructions. In part 1, set up the topology and initialize devices. Cable the network as shown in the topology. Attach the devices as shown in the topology diagram and cable as necessary. Power on all the devices in the topology. So coming to our topology, here we can see we will have this router, a switch, and these end devices. Now coming to the topology design, we will use this 4221 router, but here we cannot see that router. No, it's not there. Okay, we will use this 4331. Then we will have a switch. We will rename this router as R1. We will use a 2960 switch. Then we will rename this switch as S1. Then the end devices. Here is one and here is one. This is PC-A and this is PC-B. Coming to the connectivity, we will use copper straight through to connect from S1 to PC-A. First Ethernet 0/6 to this PCA. Then from R1 gigabit Ethernet 0/0/1 to this switch. First Ethernet 0/5. Then we will connect from router to PC-B. Here, as specified in our instructions, even we can use this copper straight through cable to connect these same devices. I mean this router R1 and this PC-B. Because nowadays in all the new devices they enabled the technology called MTIX, so it will consider the cable automatically. Anyways, here we are going to use this copper crossover to connect this router R1 and PC-B. Here we will connect 2 gigabit Ethernet 0/0 to this PC-B. Next is initialize and reload the router and the switch. Yes, here these devices are ready to configure. Now we will go to part 2, configure devices and verify connectivity. In step 1, configure the PC interfaces. Configure the IP address, subnet mask and default gateway settings on PC-A. Also configure the IP address, subnet mask and default gateway settings on PC-B. We will do that. We will get its IP address. Coming to PC-A, here we can see its IPv4 address. We will copy that. Coming to PC-A, desktop IP configuration. Here we will set that. It's subnet to mask and then it's a default gateway. Now coming to IPv6 address. Okay, it's here. We will copy that address. Then it's a prefix /64. Then it's IPv6 gateway FE80:1. Now we will go to PC-B, desktop IP configuration. Here we can see its IPv4 address. Then it's a subnet to mask and it's a default gateway. Coming to IPv6 address. And here we can see it's a prefix and it's a link local address, the default gateway. /64 and IPv6 gateway FE80:1. Now we will go to step 2, configure the router. Console into the router and enable privileged exec mode, then enter configuration mode, then assign a device name to the router. Okay, coming to R1, we will go to CLI. Would you like to enter the initial configuration dialog? No. We will configure, enable configure terminal, then we will set the host name as R1. Now set the router's domain name as ccnalab.com. We will copy this domain name, IP domain name as specified, ccna-lab.com. Disable DNS lookup to prevent the router from attempting to translate incorrectly entered commands as though they were host names. Okay, we will disable IP domain lookup. No IP domain lookup. Encrypt the plain text passwords. Here we did not configure any plain text passwords, but we are going to configure that. So just we will encrypt all the plain text passwords using this command, service password encryption. Now configure the system to require a minimum 12 character password. Okay, we can set that security, it's passwords minimum length as specified, it's 12 character. Here we can see that minimum length of all user enabled passwords. Okay, then configure the username. Here we can see that username, we'll copy that with an encrypted password of, okay, this password we can do that. Username, we already copied that. Then we will give the password as a secret. We will copy this password. Okay, then press enter. Now generate a set of crypto keys with a 1024-bit modulus. Okay, we can do that using the command crypto key generate RSA. Then press enter. Here we have to specify how many bits in the modulus. As specified, it's 1024. Then press enter. Here we are doing all the basic configurations what we studied in the first module. Just we are recalling all the concepts. Okay, then assign the privileged exit password to this one. We'll copy that password. We will enable a secret. Here is the password. Next is assign this password, little complicated password. Okay, as the console password. Configure sessions to disconnect after 4 minutes of inactivity and enable a login. We will configure this console password. We will copy this password. Okay, coming to our R1, we have to go to line console 0. Then we have to set the password as specified. It's here. Okay, then we have to give exit timeout. So we can give in minutes. The specified, I think it's 4 minutes. Okay, we can give 4. Then we have to give the command login. Next is assign this password as the VTY password. Configure the VTY lines to accept SSH connections only. Configure sessions to disconnect after 4 minutes of inactivity and enable login using the local database. We will copy this password. Then coming to configuration, we will go to a line VTY. We will configure a password for all the lines. That means from 0 to 15, all the 16 lines we are going to configure the password. We will set the password. It's here. Okay. Then we will set the exit timeout. It's 4 minutes. Yes. Also, we will transport the input SSH, and we will give a login local. Now we will create a banner that once anyone accessing the device, that unauthorized access is prohibited. We will exit banner MOTD. We will start with the delimiter and the message unauthorized access is strictly prohibited. Now enable IPv6 routing. Okay, we can enable that. IPv6 unicast routing. Next is configure all three interfaces on the router with the IPv4 and IPv6 addressing information from the addressing table above. Configure all three interfaces with the descriptions. Activate all three interfaces. We will do that. Coming to our addressing table, here we can see router R1 gigabit ethernet 0/0/0 and 0/0/1. Also we can see a loopback interface. Coming to R1, first of all we will configure gigabit ethernet 0/0/0 which is connected to this PC-B. We will go to that interface gigabit ethernet 0/0 and we will set a description for this interface. Oh sorry, we have to go to the interface is gigabit ethernet 0/0/0. We will do that 0/0/0. Okay, now we will set the description. We will give LAN PC-B. What is that? It's a PC-B. Yes, PC-B. Then we will set its IP address. Here we can see that we will copy its IP address. Then it's a subnet mask. We will activate this interface using this no shutdown command. Coming to its IPv6 address, we will copy this address. Okay, once more we will go to that interface gigabit ethernet 0/0/0 and we will set that IPv6 address. It's here. Okay, also we will set its link local address as FE80:1. Okay, now we will configure this interface gigabit ethernet 0/0/1. We'll copy its IP address. We will exit from this interface, then we will go to the interface gigabit ethernet 0/0/1 and its IP address is here with the subnet mask. We will activate this interface by this command no shutdown. Also we will set its IPv6 address. We'll copy that IPv6 address. Okay, then we will give a link local address IPv6 address FE80:1 as a link local. Also we will set a description for this interface. Description, it's a S1 LAN. The router should not allow VTY logins for 2 minutes if 3 failed login attempts occur within 60 seconds. Okay, we can give that. It's a login We have to block for it's I think 2 minutes, so we have to give it 120 seconds. Then attempts for 3 times. Okay, then within 60 seconds. Set the clock on the router. We will verify the clock now. Show clock. Okay, we will correct this clock set. So we have to give our minute and seconds. 10, then 0 1 0 0. Then we have to give a day of the month. 20. Then we have to give the month. It's April. Then we have to give the year. 2020. Okay, then we can verify the clock. Show clock. Okay, it's set. We can set this clock as per our current time. Now save the running configuration to the startup configuration file. We can do that. Copy running config startup config. Okay, we have a question. What would be the result of reloading the router prior to completing the copy running config startup config command? Obviously we will lose the configuration, because whatever we configured, everything is in the RAM. So we have to save from this RAM to NB RAM. We know that RAM is a volatile memory, so we have to store it permanently. We have to use this command, the copy running config space startup config. That means from RAM to NVRAM. Now we will go to step 3, verify network connectivity. Using the command line at PC-A, ping the IPv4 and IPv6 addresses for PC-B. Also they given a note here. It may be necessary to disable the PC's firewall. Okay, here they talk about the real systems. We have to disable this PC's firewall to ping. Okay, where the ping successful, we will verify that now. Here we will get the IP address of PC-B. Okay, IP address, we will copy this IP address. Then coming to PC-A, we will go to command prompt. And here we will ping to PC-B using its IPv4 address. And here we can see we get the replies. Now we will ping to its IPv6 address. We will copy its IPv6 address and we will ping to that IPv6 address, and here we get the replies. So we able to ping to PC-B from PC-A to its IPv4 as well as to its IPv6 address. Next is remotely access R1 from PC-A using the Teratame SSH client. Using Teratame on PC-A, open an SSH session to the R1 loopback interface IPv4 address. Ensure that the SSH radio button is selected and then click OK to connect to the router. Login as this username with the password. Okay, was the remote access successful? We have to verify that. First of all, we will see our loopback 0 in this router R1. Okay, we have to give this password. Here is our password. We have to search for it. It's here. We will copy that little complicated password. Okay, then enable. Here is password. Then we will check show IP interface brief, and we will verify loopback 0. I think it's not configured. We have to add that interface loopback 0 and we have to assign IP address. Okay, actually we did not do that. We will do that now. So we will create that interface. First of all, we will go to configure terminal, global configuration mode, then interface loopback 0, and here we can see that interface changed state to up, and here we can see that protocol also changed state to up. Okay, that's good. IP address, we will get its IP address from our addressing table. It's here, we will copy that, and the prefix /24 you'll paste here. Then it's something to mask. Okay, also we have to configure its IPv6 address. We will get that from our addressing table. Okay, also we will set its IPv6 address FE80:1 as link local. Okay, we're done. Just we will copy this loopback IP address. Then coming to PC-A, just we will ping to that loopback and we will try. Yes, it's working. Now we will try to access this router R1 using this PC-A using SSH. Okay, it's here. Try that. We will get the format SSH. We have to give a SSH space -L then username. Here is username. We will copy that. Okay, then it's target IP address. It's here. Okay, and here we can see it's prompted for the password. Password is here. We will copy that and paste here. Enter. Yes, and here we can see the banner MOTD, unauthorized access is strictly prohibited, and now we are in our router R1. Next is using Teratem on PC-A, open an SSH session to the R1 loopback interface IPv6 address. Ensure that the SSH radio button is selected and then click OK to connect to the router. Login as this username with the password. The IPv6 address should be surrounded with square brackets like this. Okay. Was remote access successful? We will check that. Go to our PC-A, and here we will give a SSH space -L space username. It's here. We will copy that. Okay, then its IPv6 address we will get from our addressing table. Loopback 0 IPv6 address, and we will paste here, then enter. Here we can see it's prompted for the password. We will give the password, little complicated. We will copy and paste, and here we did not use this square bracket. Be able to access this router R1. Now we have a question: why is the telnet protocol considered to be a security risk? Yes, obviously when we use a telnet, it will use a plain text passwords, so it's not secure. So that we can use SSH, which will use encrypted password. Now coming to part 3, display router information. In part 3, we will use show commands from an SSH session to retrieve information from the router. Establish an SSH session to R1. We have to use Teratem on PC-B. Open an SSH session to the R1 loopback interface using IPv6 address and login as this username and password. We have to do it from PC-B. Just we will copy from PC-A. Here is our session. We'll copy it. Now coming to PC-B, command prompt, and we will paste here. And it's prompted for the password. It's here. Here we can see now we are in router R1 using SSH. Step 2, retrieve important hardware and software information. Use the show version command to answer questions about the router. What is the name of the iOS image that the router is running? We will verify that using show versions, and here we can see the details. We will expand it and we will check for the iOS name. Coming to its output, here we can see its name, Cisco iOS software, ISR software, and here we can see its name. And here we can see a version, it's a 15.5. Next is how much non-volatile random access memory, that is NVRAM, does the router have? Also, how much flash memory does the router have? Okay, once you come down here, we can see 3 gigabit Ethernet interfaces, and here we can see non-volatile configuration memory. It's here. Also, we can see this much bytes of flash memory at boot flash. The show commands often provide multiple screens of outputs. Filtering the output allows a user to display certain section of the output. To enable the filtering command, enter a pipe. Here we can see that character after a show command, followed by a filtering parameter and a filtering expression. You can match the output to the filtering statement by using the include keyword to display all lines from the output that contain the filtering expression. Filter the show version command using show version, then pipeline, include register to answer the following question. What is the boot process for the router on the next reload? We will try with this filtering command. Okay, it's a show version, then pipeline. We have to include register, and here we can see the details. Configuration register is here. Next is step 3. Display the startup configuration. Use the show startup config command on the router to answer the following questions. How are passwords presented in the output? We'll give that command show startup config. I think we have to go to a privileged exec mode, enable, and here we have to give that password, privileged exec password. It's here. Okay, we'll paste it here. Then we will give that command show startup config, and here we can see the details. We can see all the passwords are encrypted because we given a service password encryption. Here we can see enable secret, it's already encrypted. Then here we can see console, line VTY and line console. All passwords are encrypted. Now use the show startup config pipeline section VTY command. Okay, we will try that. Show a startup config pipeline. Then we have to give section VTY. Okay, we will try that. Section VTY. And here we get an error. Okay, anyways, we will go to step 4, display the routing table on the router. Use the show IP route command on the router to answer the following questions. What code is used in the routing table to indicate a directly connected network? Also, how many route entries are coded with a C code in the routing table? Okay, we will give that show command. It's a show IP route. And here we can see directly connected networks indicates C for connected. And here we can see total 1, 2 and 3 connected networks. Now we will go to step 5. Display a summary list of the interfaces on the router. Use the show IP interface brief command on the router to answer the following questions. I think already we given this show command, but still we will give this show command and we will answer these questions. What command changed the status of the gigabit Ethernet ports from administratively down to up? Obviously, when we given the command no shutdown. Anyway, we'll give that show command here. Show IP interface brief. And here we have seen the status up for these three interfaces G0/0/0, 0/1, and for loopback 0. And for other interfaces, that is gigabit Ethernet 0/2 and VLAN 1, we can see its status administratively down, also protocol down. So here when we given that no shutdown command, this interface status become up. Next is use the show IPv6 interface brief command to verify IPv6 settings on R1. What is the meaning of the up part of the output? Okay, we will give that command here. Show IPv6 interface brief. Here we can see two up bar up. That means one is status up, then protocol up. Now on PC-B, change its configuration so that it no longer has a static IPv6 address. You may have to reboot the machine, then issue the ipconfig command on PC-B to examine the IPv6 configuration. Okay, we will do that. Coming to PC-B, here we will go to IP configuration. Here we can see now we are in a static and we are saying this IPv6 address, its prefix and its IPv6 gateway. Here we are going to give auto config, and here we can see now it's IPv6 address, IPv6 gateway and its prefix. Okay, we will verify it using command prompt. We will use the command show, sorry, it's IPv6 config or and here we can see its address IPv6 address. Here we can see link local IPv6 address, then a default gateway. So fully you can see IPv6 address here 2001 colon db8 colon acad colon 0. This IPv6 address made using its MAC address. Then we can see default gateway FE80:1. Here we can see what is the IPv6 address assigned to PC-B. So here we can see that IPv6 address assigned using its MAC address. What is the default gateway assigned to PC-B? It's FE80:1. Now issue a ping from PC-B to the R1 default gateway link local address. Was it successful? Okay, we will try that. We have to ping to its default gateway. Okay, here we will ping to that IPv6 address, and here we get the replies. It's working. Next is issue a ping from PC-B to the R1 IPv6 unicast address. That is 2001 colon db8 colon acad colon double colon 1. Was it successful? We will verify that. Ping to its unicast IPv6 address, it's working. Now we have two reflection questions. In searching a network connectivity issue, a technician suspects that an interface was not enabled. That means he forgot to give no shutdown command for that interface. What show command could the technician use to troubleshoot this issue? Obviously, we can use the show command show running config. If we saved, we can use a show startup config. Also, we can give show IP interface brief so that it will show its status as administratively down. Next is in researching a network connectivity issue. A technician suspects that an interface was assigned an incorrect subnet mask. What show command could the technician use to troubleshoot this issue? Okay, for this issue we cannot give show IP interface brief, because in that we will get only its IP address, then its status and protocol status. But if you want to check this subnet mask, we can give show running config, we can give show startup config, also we can give show interfaces. Okay, so friends, in this video we discussed our lab activity, configure basic router settings. Now, dear friends, if you have any doubt, any suggestions regarding this lab activity, please comment below. Also, if you like our video, give a thumb and share with all your friends. And if you like to get more technical contents, or some people wants to contact our team, then you can visit our website so that you can contact us. Stay tuned, and we will meet again with the next video. Thank you.